Welcome to the first episode of Aviator 90 from Angle of Attack. We're very excited to get started. Before we dive into this first section, let me note that the first 5 episodes, starting with this one, are the intro to flight. We'll cover lift, the other 3 forces, control surfaces, trim, and the cockpit in that order. This time, we'll be talking about lift. Now, the first thing that you need to learn as a virtual pilot is what makes aircraft fly. The magic word we're looking for here is called lift. The first thing that comes to mind for me when thinking about lift is simply lifting a box or some other object. It means the object comes up. Lift is a phenomenon that allows an airfoil, like a wing, to take flight. Although not all wings are created equal, they all create lift with basic principles. We will now go over a few of these theories as to how lift is created, and then we'll talk about a few more things. The push theory is the theory that is the most simple to understand, so we won't take as much time on this one as we will in the next one. Now, the push theory says that as the pitch or angle of attack of a wing is increased, the more it forces down the air underneath it, pushing the air down and therefore pushing the wing up. This is the simplest way to explain lift. Although this is simple, it is actually based on Sir Isaac Newton's third law of motion. I'm sure you've heard it before. To every action, there is an equal and opposite reaction. Now let's move on to the next theory. This theory explains lift as follows. The air traveling on the bottom of the wing has less distance to travel than that of the top of the wing because of its shape. Therefore, the air on the top of the wing has to travel faster in order to catch up with the air on the bottom of the wing. The Bernoulli principle then states that as the air mass moves faster, the pressure decreases on the top of the wing. So the top of the wing has a lower pressure, and the lower part of the wing has a higher pressure. This is said to push the wing up. Now, think of it this way, as that might have been a bit confusing. Say you have a helium balloon. Now, we all know from childhood experience that if you let go of that balloon, it's going to surge upwards and it's a goner. That balloon is very light and seeking a low pressure, as the air down here at the surface is much more dense than the helium within the balloon. So, this area of higher pressure is seeking an area of lower pressure. Therefore, it forces the wing up. I hope that makes sense. In all reality, usually us pilots don't have a lot of mathematics or physics training, although some do have a bit. As a result, we have to resort to less complex explanations for aerodynamics. Both of these theories sound convincing, and the truth is that much of what happens with lift is very scientific and based on real equations, so let's make that clear. These are things I don't pretend to know, but usually the aircraft manufacturers do have it figured out. Angle of attack is not just a fancy name for our company. It's actually one of the most important aerodynamic principles you can learn. The angle of attack is described as the angle between the chord line of the wing and the relative wind. By increasing this angle, greater lift is produced. This doesn't mean you can simply climb limitless with an increased AOA, as other factors come into play. It does, however, turn a normal airfoil into a climbing machine. Can you now see why we named our company Angle of Attack? Flight is not possible without angle of attack. It's worth noting that not all wings are created equal. Wings come in many different shapes and sizes. If you were to make a cross-section of different wings, you'd be able to see this firsthand. This cross-section shape is known as an airfoil. Each airfoil has its own unique camber, which is the relation between the top shape of the wing and the bottom shape of the wing. Wings can also have a different camber from the root of the wing to the tip, giving them different control characteristics in different flight situations. Now, to wrap up this lesson, just remember that lift is created as a result of basic principles in physics and mathematics. By then increasing the angle of attack, this lift can be increased. Lift is essential for flight. Now, I consider lift and flight to be a miracle. I understand that there is a perfectly sound explanation for all of it, but I still find the fact that we can fly to be a miracle. In the next lesson, we'll learn about the other 3 forces of our aircraft, as lift is only one of the 4 forces of flight. Until then, throttle on. Welcome to another episode of Aviator 90 from Angle of Attack. In the last episode, we discussed lift and why it is essential for flight. Now we will talk about the other 3 forces of flight. You may have remembered one of Sir Isaac Newton's laws that I mentioned, which is, for every action, there is an equal and opposite reaction. With that said, I'll now teach you what I know about the other forces on the aircraft. Because last episode we talked about lift, I find it appropriate to talk about weight. Weight is the opposite of lift. Out of all the forces, I consider this to be the simplest of the forces of flight because it has a few key aspects that we are both familiar with. First, a plane is not lighter than air, therefore it'll fall without the lift component. Second, gravity. We all know what this is, and thank goodness for it. Otherwise, this whole flying thing just wouldn't mean anything to us, because everything would be off the ground all the time anyway. In all seriousness, gravity is obviously the biggest contributor to weight. You can see why it's opposite to the force of lift. Thrust can be described in general terms as the force that moves the aircraft forward. This force largely relies on Newton's third law, again, as you'll see. We'll be using a propeller in the aircraft we'll be flying in Aviator 90, so let's talk about how the propeller creates thrust. A propeller turns at a rate determined by the pilot as a result of engine power. The prop is at a pitch, or angle of attack, just like the wing we discussed in the lift section. The propeller essentially creates lift forward rather than up. This pulls the aircraft forward and also sends a blast of air back that assists a bit with airflow over the control surfaces. If an aircraft produces enough thrust to outperform drag, and we have a sufficient airfoil, the aircraft will fly. Drag is generally described as the forces upon the airplane that are pushing it back. These forces are basically friction, disruption, and resistance to airflow created by the forward thrust the aircraft is creating. Drag is broken up into several different types, which are friction, form, induced, and parasite drag. We'll now talk about each one of these. Friction drag is caused by the airflow around the airplane. As the air goes around the airplane, it comes in contact with the aircraft and creates friction as it touches. This in turn creates drag. Form drag is actually something we're all familiar with as it is very prevalent in car designs. It is basically how the shape of the aircraft interacts with the air flowing around it. Now, a sports car will be built in such a way that form drag is reduced. Smooth, sleek, and with the least resistance possible. Aircraft, as you can imagine, are built in the same way. You don't see a big Vanagon flying around now, do you? This would not work. Induced drag is created as a result of lift that is created by the wing. You may or may not be familiar with winglets present on some airliners. These winglets are in place partially to reduce this very kind of drag because spoiled air is formed at the tips, and these winglets reduce that spoiled air. Parasite drag is anything on the airplane that can produce drag such as rivets, antennas, pitot instruments, etc. Parasite drag can even be produced by an extremely dirty airplane or a little frost on the airplane, believe it or not. Let's look at a few different phases of aircraft operation and see how the forces relate to each other. Now, in straight and level flight, lift is equal to weight and thrust is equal to drag. When lift and weight are equal, you stay in the same place, right? When descending, weight is greater than lift. Why? Our gravity is getting the better part of us, pulling us down. Obviously, angle of attack would have something to do with this as well. When climbing, lift is greater than weight. Why? Because we are defying gravity and pushing through it. Again, angle of attack does have a play in this situation. When on the ground and not moving, weight is greater than lift, keeping our wheels planted, and thrust and drag equal 0. You may think that these forces of flight aren't critical to flight, but they are. Everything you do in the air is a result of the relationship between these forces. Absolutely everything. Give yourself a big pat on the back. We can now move on to more advanced things. Next, I'll teach you about control surfaces. Until next time, throttle on. Welcome back, fellow aviators, to another round of Aviator 90 from Angle of Attack. We left last episode with one thing left to teach about the secondary flight controls. That control is trim. Trimming, in my opinion, is one of the most important skills an aviator can learn. It is going to be quite difficult to tell you why trimming is so important, so for now we'll learn what trim is, why it is important, and how you can expect to use it while flying. Trim is used to relieve pressures for primarily the elevator, but there may also be separate trim for the rudder and ailerons. The trim tab on the elevator can be seen here. If you don't have the trim set for your simulator through your yoke, joystick, or even key commands through your keyboard, you must do that now, right after this episode. While flying, I generally like to keep my aircraft flyable with my thumb and forefinger. This stable flight condition is only possible by use of a properly trimmed aircraft. In Flight Simulator, you aren't going to be able to feel the forces of the yoke pull the aircraft. You will, however, be able to see what the aircraft is doing in relation to the setting you want. It's much more difficult to trim in Flight Simulator than it is in real life. By trimming the control pressures on the elevator, for example, you won't have to hold the yoke in constant pressure to maintain a desired situation, say an airspeed. Rather, by setting the trim correctly, you can release all pressure on the yoke to where it goes back to neutral, but the aircraft is still in that desired position. This is all thanks to trim. If you don't trim, you are going to have sore muscles and a nice sweat. You've got to learn how to trim. Let's go over some scenarios and we'll look at the correlating trim adjustments that are needed. Say you want to fly straight and level, but the aircraft is pulling you up. By then pushing the trim wheel forward or up, you can trim off the extra pressure needed to stay straight and level. It may take large adjustments at first, and then you can fine-tune from there. Let's say you are climbing at full power, but you want to maintain a certain airspeed without constant pressure on the elevators. Control the yoke by pushing or pulling until you find the exact airspeed you'd like to keep. If during this transition you find that you'll need to start trimming in that direction to make it easier, go ahead and do so. Now, fill the yoke. What pressures are you feeling? Are you pushing the nose down, pulling it up? Adjust as needed so you could let go of the yoke and it would still climb right at that airspeed without any pressure. These are just a few small examples. It's important to note that trim is very important for takeoff, as an incorrectly trimmed aircraft can result in a very dangerous situation. Just place the trim wheel in the green or takeoff area of the wheel during pre-flight or taxi and you'll be set. Later on, you'll learn a lot more about trim, and I'll do my best to share my trim adjustments as they are happening. For now, we are done. During the next episode, I'll teach you about the cockpit with its controls, instruments, switches, and so on. Until then, throttle on. Welcome back to another masterful episode of Aviator 90 from Angle of Attack. Alright, so we're nowhere near masterful. All the same, let's move on. Last episode we discussed trim and its importance for stable and smooth flight. Before we jump in the cockpit and take this bad boy for a spin, I'd like to introduce you to the cockpit and give you a brief overview of everything in it. We are going to go from the top to the bottom, left to right, like we're reading a book. Lining the top of the instrument panel is the glare shield, which reduces the glare from the sun and also helps encompass all of the instruments. On the left side of the instruments, we find what we call the basic 6. These instruments are what is used in basic instrument flight, as they give us all the indications we need to fly correctly, even when we can't see outside. Top left is the airspeed indicator. We'll go over the many aspects of this instrument throughout the training, but keep in mind for now that there is more than meets the eye. To the right of the airspeed indicator is the attitude indicator. This indicator is central to everything we do and the most important of all the instruments. Here we can see the relative position the aircraft is in comparison to the horizon and sky, and we also see the bank indications. Top right on the basic 6 is the altimeter. This instrument shows us our altitude above mean sea level, MSL, in feet. The small hand is for thousands of feet, and the longer hand is for hundreds of feet. Bottom left on the basic 6 is the turn coordinator. This instrument gives us indications to coordinate turns as well as indications for 2-minute turns. More on that a bit later. To the right of the turn coordinator is the heading indicator. Unlike the magnetic compass, this heading indicator is much easier to use and doesn't have the degree of errors compared to that of the magnetic compass. Last but not least is the vertical speed indicator. This indicator lets us know how many feet we are climbing or descending in feet per minute. That does it for the basic 6. Now, just to the right of the basic 6 is the VOR and ADF instruments, top and bottom. We'll use these instruments for cross-country navigation, as you'll see later. Now, looking in the middle of the panel, you can now find the radio stack. Starting from the top, we have the VHF radios, or comms, ADF tuner, and the transponder. The VHF radio allows us to communicate with air traffic control, ATC, and other aircraft. This is used often. You'll learn how to communicate well through Aviator 90. The ADF is simply tuned here. Not much else to be said about that right now. Last but not least is the transponder. This instrument is used to ping our position and altitude to air traffic control. When we are under control, we'll give a squawk code, as it's called, to place here. This is a 4-number code that is unique to our aircraft. Now, moving along the radio panel, we find the RPM indicator, or tachometer. This shows how much power the engine is producing. You'll certainly see where this comes in handy later, but for now, just know that you must not go over the red line. You can be right on it, but do not go over. Next, top right on the panel is the amperes that indicates how much juice the battery is charging or discharging. Moving down to the bottom of the panel in this area, we'll break it up according to this line. The parking brake is located here, used when parked or running up. Pull and depress the brakes and it'll set. Oil temp and oil pressure are next and should be kept in the green values when above 10,000 RPM. Left and right fuel quantity indicators are seen here. Now, one thing I should say at this time is to never trust these. Always do your fuel planning manually. These are for verification purposes only. Carb heat is located here, and we'll actually talk about that a bit later as well. The throttle is located here, which is the primary control for engine power. Next to the throttle is the mixture. This mixture controls the fuel. This must be adjusted depending on altitude, so we are getting the most efficient fuel burn out of the current situation we're in. Flap controls are located here, and they have different detents, so they are easy to put down and pull up. Cabin air and cabin heat are located here for comfort, but lucky you, Flight Sim doesn't model the freezing temperatures or humid heat that is often experienced as a pilot. So moving down to the bottom part of the panel now, we come to the primer. This is used for engine start. The master switch is located here. It lives up to its name. It is the master of all power to the aircraft systems. Without this, you wouldn't have electronics. The magneto and start switch is located here. In this area, we will find the lights for the aircraft, both interior and exterior. We'll be learning when it's appropriate to use these different lights at a later time. The trim wheel comes next, which you have seen in the last section, so we won't rehash that now. Circuit breakers are located here for abnormal and emergency circumstances. So as you can see, there's still a lot to learn. By getting in the cockpit and looking at all the different switches and controls within our reach, it's even more important to learn what these things do and how to operate them. So with that said, don't be too overwhelmed on how to use each and every switch for now. Let's take one thing at a time. Once we actually get this thing moving, things will come to you much easier. For now, I'd like to congratulate you on completing the Intro to Flight section. It's now time to move on to the Basics of Flight section, where we'll finally get up in the air. Until next time, throttle on. Welcome to another episode of Aviator 90 from Angle of Attack. You have just finished the first 5 episodes of Aviator 90, which was the Intro to Flight. Now we move on to the next 5 episodes, which we call the Basics of Flight. We will now learn more about actual flight techniques. The sections you will learn are ground ops, takeoff, power management, turns, and pitch. We'll be showing techniques within the aircraft to assist you in learning how to use better control. So we start with the first lesson this episode, which is ground ops. Now in the real world, you don't just get to load up a flight and start midair near your favorite world landmark. Nope, not that easy. As a virtual pilot, it's important to know how to do ground operations, things like taxiing, ground communications, airport signage, and other things to watch out for. We will be learning some of these techniques in this episode. Later, we'll dedicate a whole episode on just starting up the aircraft, so we won't be doing that for now. First, let's start out after having just barely started up the airplane and turned on the avionics. Now, here we are sitting on the ramp, and you'll notice the beautiful Pacific Northwest scenery from Orbix. We're going to go through several things while we're sitting here, so I'll list them now and then we'll burn through them. We'll first give the traffic frequency a call and get a radio check, listen to the weather observations, and then we'll power up for a short taxi to the runway. In the run-up area of the runway, we'll be going through a couple pre-flight checks. I'll be doing the run-up this time, and next time we will actually just go through the takeoff, so you guys won't have to worry about learning the run-up this time. So at that point, the lesson will end. At non-controlled airports, which are common, we talk on what is called a CTAF, which stands for Common Traffic Advisory Frequency. In short, it's a frequency that all pilots in the area use to make position reports and so on. It can also be used for radio checks and other necessary things needed for flight purposes or aircraft operations. It is up to us virtual pilots to report our position and intentions so everyone in the area can build a picture in their head of where we are, what we're doing, and if there's a potential conflict with what they are doing. You'll see what I mean later. Now, before taxiing out, we need to make sure our radios work and that we're on the right frequency so others will hear our radio calls. Do this by addressing the CTAF, say your tail number, then ask for a radio check. It's as simple as this. Tillamook Unicom, Cessna 6828 Kilo, radio check please. If you are unfamiliar or uncomfortable with making radio calls, I want you to say it out loud right now to yourself. I know this may be kind of silly, so in this order: airport, aircraft, radio check. That easy. If a friendly voice is in the area, they'll return with a loud and clear or 5x5. This means you are good to go. Alright, it's now time to check the weather. I simply hit the tilde key, which is the top left button on the main area of the keyboard, and then I hit the number of frequency I want to tune to. So in this case we want to tune to the ATIS. You may choose to manually dial the frequency, which adds a bit of realism as well. So regardless of how you chose to tune, the voice will come up and give you a long list of information. I don't expect you to know everything for now. So for now, just listen for two things: the wind direction and speed, and the altimeter setting.
Sierra 47, automated weather observation 2310, Zulu, wind 0, Niner 4 at 7, visibility 10, sky condition clear, temperature 24 Celsius, dew point 22 Celsius, altimeter 2870, Sierra.
We'll now use the wind direction and speed of 094 and 7 knots to determine the runway we'll use. Because the wind is coming from 094 at 7 knots, we'll use runway 13 for our main runway. This is the closest match to that runway heading of roughly 130, which is actually how they get those runway numbers. If ATC gives you a different runway to controlled airport, you can always ask for a different runway. They may not give it to you, but you can always ask. Now take the altimeter setting, in this case 28.70, and place it in the Colesman window here on the altimeter. This means we're now tuning the altimeter to a pressure of 28.70 inches of mercury. This should match the field elevation, but don't worry about that for this flight. Now that we know the runway we need to taxi to and we have our altimeter set, we'll now announce our intentions, and then you can follow along with me as we taxi to the runway. I'm familiar with the airport and know where to go, so if you want to simply watch the first time, no problem with that at all. I'll make the radio call this time. Tillamook traffic, Cessna 6828 Kilo, taxi from self-serve fuel to runway 13. Notice I addressed the area, said who I am, where I'm going, and you can also say how you're going to get there if you're using a specific taxiway. Confused yet? Maybe or maybe not, but no worries for now. You'll pick it up along the way. Push the throttle forward to get about 1000 RPM on the tachometer. This setting will get us rolling. Give a quick tap on the brakes right after you start moving to make sure they are operable and not mushy. We don't want to get up to taxi speed before we realize the brakes won't work. With feet on the pedals, tap the toes of your right foot and the toes of your left foot, checking the brakes. Alright, all good, let's taxi on. Directional control during the taxi is done with a linkage of the rudder pedals at your feet to the nose wheel and the rudder on the aircraft. Pushing your right heel will turn the aircraft right, and pushing your left heel will turn the aircraft left. Pretty simple, isn't it? Now, I recommend rudder pedals in flight sim if you don't already have some. It makes the taxi part of the flight very enjoyable and adds a ton of realism. Before we forget about our power, let's make sure that we keep our speed anywhere from 10 to 20 knots in the straightaways and 10 knots or less in turns. At this point, you'll probably have to bring the power down if you haven't already done so. Also, remember to always have centerline pride. Stay right on that center line and don't deviate from it. This will take practice with the rudder pedals. You can also think of this as aim small, miss small. The key here is to keep the aircraft under control to where you can pretty much stop immediately if needed. Go above 20 knots and that becomes an issue. Get all squirrely with your steering and the speed works against you. You've got to find a happy balance with foot movement to keep that center line, and also power management to keep the speed in check. If you're taxiing on your own right now, do your best to keep that center line and maintain a safe speed. Don't worry about being perfect the first time. Your skills will get better with practice and experience. That's just the way it is. We're now coming to the run-up area for this runway, and where we'll do our engine tests and other things. I'll actually perform them this time, as I mentioned before. So get as close to the end of the pavement as you can. Put some pressure on the right brake and right rudder pressure so we can turn on a dime and add some power. Alright, keep bringing it around until we can face into the wind. We're facing to the wind now, so bring the power back and smoothly apply the brakes. Bring the rudder neutral and come to a stop. Alright, that does it for this episode. Great job on the radios and the controls. This time around I'll handle the run-up and checks as I said, and we'll meet next time when we're ready to taxi onto the runway and take off. So for now, you don't have to worry about the boring stuff. Until next time, throttle on. Welcome to another episode of Aviator 90 from Angle of Attack. Finally, it's time for the takeoff episode. I'll do my best to explain takeoff technique for you, and hopefully you can take that knowledge into your own sim. So I have completed the run-up, and you'll notice we're in the same place we were last time pretty much. Before we taxi onto the runway, we're going to do the lights, camera, action checklist. Lights, we're simply going to turn on the strobes and landing lights. Although strobes aren't on this aircraft, strobes are used for the duration of the flight from taxiing on the runway until we get to our destination and pull off the runway. So runway to runway. The landing lights will turn off when we leave the pattern and when it makes sense. Now the camera is when we turn on our transponder. A transponder allows ATC to get our information so they can track us. Most modern transponders are Mode C transponders, which report altitude as well. The default VFR setting for a transponder for rules under VFR when not under control is 1200, so make sure that's set as well. It should already be in the window. Action is when we simply do a 360-degree turn here on the ground and clear the airspace around us to make sure that we know where everyone is. It's a big action because it's quite a big turn, so that's why we call it action. So here we go. Let's whip this around, scan for traffic, and ensure no one is in conflict. The easiest way to turn on a dime, as you saw in the last episode, is to hold down the brake on the turn side about 3/4 of the way, as well as pushing the rudder on that side. So what we're basically doing here is we're scanning the airspace around the airport and making sure that there aren't any other aircraft that are going to come in conflict with us. And we want to make sure that the runway we're actually departing on isn't in conflict with the type of pattern that they're doing, which you'll learn later on. So I'm not seeing any traffic, so once you round out the turn, start heading toward the runway hold short lines. As we pull up into place here, we'll make sure we do not pass this line. This line represents the runway area, and without stating we are pulling onto the runway or getting permission to do so, we cannot cross these lines. These are known as hold short lines. At this stage, it's important to make sure you aren't cutting someone off who is on final. If you do cut someone off, this is called a runway incursion and will get you in a ton of trouble. Alright, so all checks are done. We've done lights, camera, action. Now let's state our intentions and pull onto the runway. Tillamook traffic, Cessna 6828 Kilo taking 13 for departure, will be southeast bound. Alright, so ease the power forward and come to a nice stable taxi speed. As you pull onto the runway, look toward the direction that others would be landing and clear the final. Verbally say it, final, clear. We want to make sure that no one else is landing as we're pulling onto the runway. Now taxi as to use up every little bit of runway at the end. This means you'll get your wheel as close to the edge of the pavement as possible without going off the pavement, obviously. When it's time to turn and line up with the runway center line, give the rudder pedal heel a big push in the direction of the turn. Now, you can also turn even sharper by partially holding down the brake on that same rudder pedal. So get all lined up and then we'll get this show on the road. Or I guess in this case it would be sky. Alright, whatever, you get it. Hold the brakes firmly and fully and ease the throttle forward. Bring the engine up to full power and monitor the engine instruments and listen to the sound of the engine for a few moments. No problem, so release the brake, keep light forward pressure on the yoke, and keep on track with that center line with rudder input. Now, the plane will want to pull left quite a bit, so you'll have to counteract that. Keep on that center line and start to release pressure on the yoke. Now, 55 knots is coming up, so smoothly ease back on the yoke and unstick those wheels. Sometimes it may take just a tiny and quick jerk to get the wheels off the pavement. Alright, you're airborne. Now, adjust your pitch up and down to maintain our climb of VX, which is 55 knots. So, maintain that same rotational airspeed. Nose down, you'll go faster. Nose up, you'll go slower. So, adjust accordingly. Now lift your head if you're able and make sure that you are tracking along the runway center line. So you'll have to adjust for the wind. You can even try looking behind you if possible. So if something was to happen, we may have enough runway to touch down again. So it's important we stay right over the runway. You'll have to adjust by turning into the wind, as I said before, and letting the aircraft track down along that center line. Alright, good job. Hopefully, like the video, you have a stable climb at 55 knots. Or you can go to VY of 67 knots and make sure you're tracking that runway centerline still. So maintain your airspeed, keep climbing, and I'll see you in the next episode where we'll talk about power management. Until next time, throttle on. Hey there again, and welcome to another episode of Aviator 90 from Angle of Attack. This time we'll be talking a bit about power management, safe airspeeds, and other basic aspects of flight. Now, usually when initially practicing to become a pilot, you just buzz around the pattern, but you guys are learning to become aviators, not pilots. Let's now run through a few scenarios with the airplane and test things out. First off, let's just fly straight and level at full power. This is generally your cruise situation. So in a small aircraft like a 152 or 172, you're going to simply be at full power most of the way, as long as we don't go past the red line on the tachometer. As you can see, we get pretty good airspeed out of the aircraft when we aren't climbing, just a nice steady pace. I'm now going to smoothly pull the power back to where the engine is idle. You'll notice without touching the controls, just the throttle, the aircraft has a tendency to pitch down and lose altitude. Now, if I was to add back pressure, you can see that the airspeed is really starting to bleed off. Once we reach the bottom part of the white arc on the airspeed indicator, this is a good indication we're about to go into a stall. So let's not go into a stall now, that'll come later. I'm going to now add full power again, smoothly but quickly. This time let's climb a bit. You'll remember this same situation from when we took off last episode. This is your typical climb situation. You'll be at full throttle and simply adjusting your pitch to maintain an airspeed. We can even maintain something like 67 knots, for example, so let's shoot for that. That's our VY on this Cessna 152 from Carinado, by the way. So pick that 67 knots, which you'll put it just above the tick in between 60 and 70. So just kind of guessing where you're at. Find that sweet spot on the yoke, the pitch that you need, and then start to trim out that pressure. Usually the best way, or almost always the best way, to climb is to just get it set up with the trim. That way you don't have to fight it the whole time. I know that some guys kind of set their trim when they're in cruise and then they don't worry about it the rest of the time. So just set your airspeed and trim off the pressure. And I'm sure that this will mainly just be something you'll learn over time, but do your best to get the aircraft set up so it's running smoothly right at that 67 knots. Alright, now let's do the opposite. Let's pull out the power again and maintain a steady descent at a specific airspeed. In fact, let's keep 75 knots throughout the entire process just so you can feel how much of a difference that power makes. This will feel a bit like a roller coaster, perfectly normal for this situation. So as you can now see, we've gone from one extreme to the other. It's like one big rainbow maneuver. This particular scenario is much like your approach to land. It's better to keep stable airspeeds throughout an approach so it is predictable and stable the whole way down. So now let's ease up to 1500 RPM, still maintaining 75 knots. We now have a very realistic and stable descent for landing profile, notably without flaps. Not bad at all. There's a saying out there that may help you remember some of these aspects. They are pitch equals airspeed, power equals altitude. Although that is generally great in theory, I want you to keep something in mind during these early moments in the air. When a pilot is more experienced, he doesn't think in his head, alright, so pitch is airspeed, power is altitude, what should I do now? Rather, he just has a sense of what to do. It may be too early to mention this now, but it's up to you to build a sense of the mix between power and airspeed and when you need to adjust them. All of your flight profiles are dependent upon knowing what you can and can't do. It's up to you to become intimately familiar with your aircraft to know how it can be handled in different situations. There's no one correct way to fly as long as it is flown correctly. Now, I suppose the argument here would be, what is correct? What's the definition? You can only determine that with your own experience. So hang in there. Now, with that said, always be smooth. I don't mean like a cool guy. Don't jerk around the controls and whip your head around. Be smooth with the throttle, the pitch, the roll, and remember eventually they'll come in handy when you have passengers. Alright, that'll do it for this episode, and if you are feeling a little overwhelmed for now and just want to watch, that's perfectly fine. We'll be back next episode talking about turns. Until then, throttle on. Welcome back for yet another thrilling episode of Aviator 90 from Angle of Attack. This time we'll be talking about turning and why it's not as simple as just turning the yoke. This episode is pretty simple, however, but it's essential to your growth as an aviator. So we're still aloft from last episode, and here we are, straight and level. let's dive right in now. Not literally, but I'll show you some turning techniques here, and then we'll talk afterwards about what we learned. So let's start a nice left-hand turn. Start this by turning your yoke or joystick in the direction you'd like to turn. If you look outside, you'll notice it seems we are now moving around on a spindle. Also, part of the point of VFR, private pilot training, is to visualize everything outside. That is, the world around you, not necessarily with your eyes in the cockpit. With that said, I'm about to contradict myself. So what comes next takes the most effort. You'll notice that we are losing a bit of altitude. What was once a stable and level flight is now losing altitude. Why, you ask? Well, when an aircraft turns, it loses a bit of its lift, and it has an increased load factor. Without going into too much detail, let's just say that the greater your bank angle, the less lift you are producing, and the greater your load factor. There will come a time, if you turn too much, that the aircraft just won't want to climb anymore and it'll want to roll and or dive. Now that's at least a story in a wee little Cessna like we have here. So to counteract this loss in lift, you can simply add light back pressure on the yoke. It won't always be the same amount, as that'll depend on your bank angle, but adjust accordingly to maintain your altitude. The next part of a turn is called turn coordination. Now, we'll be using an instrument that doesn't get as much attention as it deserves, which is the turn coordinator. Turn coordination is essential for flight. It keeps the aircraft in a smooth and slick turn. If the turn isn't coordinated, you will lose efficiency. So basically a turn can be either coordinated, which is right along the path the airplane can go, or it can get in what is called a slip or a skid. A slip is when the aircraft is cutting a turn too tight on the inside. A skid is when it is skidding to the outside of where the turn should be. By use of this ball in the middle on the turn coordinator, you can always keep the aircraft in perfect coordinated flight by use of rudder input. Now, this isn't always easy. It takes some coordination with your feet, but by stepping on the ball, you can bring the ball back to center and keep the aircraft in coordinated flight. This will take a bit of practice. Before we leave this instrument, actually not too important for now, I want to introduce you to something we'll end up using later. This is the 2-minute turn indication. If you turn the aircraft and place the wing right on this indication, like so, you will complete a 360-degree turn in exactly 2 minutes. If you place the wing halfway between the top and bottom mark, you'll get a 4-minute turn. For now, this simply gives you a nice and stable 360-degree turn. So let's go over what makes up a good turn. It's threefold: initiate, compensate, and coordinate. First, you initiate the turn by turning the yoke, sometimes even giving a light nudge of the rudder pedal. Really easy. Second, you compensate for lost lift and increased load by pulling back on the yoke. Last, you coordinate the turn as discussed. As you can see, turning isn't just as simple as turning the yoke. It takes a bit more effort and focus, but once you get it down, your flights will be smoother than ever. That does it for this episode. Next episode, we will wrap up the basics of flight with a lesson on pitch. Until next time, throttle on. We're back to wrap up the basics of flight in the Aviator 90 course from Angle of Attack. This episode will get further into pitch and how you can better use it and understand it. Although pitch isn't the whole thing that allows us to fly, it is definitely one of the more important aspects of it. So far, you've learned how pitch, when mixed with power, can assist you in maintaining airspeeds, steady climbs and descents, and even more. We have also learned a bit about trim and why it is important. So I say we wrap everything together and discuss it more. I mentioned earlier that trim is an art form that pilots must learn to use. The most important kind of trim is elevator or pitch trim. When we pitch for an airspeed, even directly after takeoff, you can literally find the sweet spot, the perfect setting with the yoke pressure, and then you use the trim wheel to slowly bring out that pressure. So once you've brought out the pressure on the yoke with the use of trim, you can literally let go of the yoke and the aircraft will maintain that airspeed and pitch. Quite fascinating, actually. For the most part, every single adjustment you make in pitch will require you to make an additional adjustment with the trim wheel, at least if you plan on staying in that condition. Eventually, you'll get to the point where you know what kind of trim input is needed for your pitch change, so you'll almost simultaneously change pitch and trim. Now, training aircraft are very stable and forgiving machines. They are made to be stable throughout all phases of flight. What I mean by this is that stability in aerodynamics terms means the aircraft, when put in an odd situation, will eventually become stable. Some aircraft are made to be very unstable. These aircraft are more maneuverable, things like stunt planes. Because we have a stable aircraft, we can count on our pitch and trim inputs to be smooth and forgiving, perfect for learning. Now, pitch does have its limits, as you have seen. When reaching a critical angle of attack and pitch, we can no longer produce lift and the aircraft will stall. A stall is when the aircraft simply falls as it cannot produce enough lift to stay up. This doesn't mean you'll just fall out of the sky, it simply means the aircraft will seek a condition of lift once again. Although we won't do stalls now, just keep in mind that all these airspeeds you're learning, all the pitch techniques and more, are there for your protection and control of the aircraft. If you are a capable aviator, you will never have to stall under normal circumstances apart from practice. Even if you are in an emergency situation, I hope to teach you that you never have to lose that supporting lift. Pitch is your best friend in this case. Pitch, even without power, can ensure you stay flying. This does it for this episode. We have now completed the basics of flight and we can now move on to actual procedures and flying techniques. Excited? I know I am. Can't wait to see you next time. Until then, throttle on. We're back for yet another episode of Aviator 90 from Angle of Attack. This time we'll be learning how to flare. Now, I can't promise that you'll get a nice and smooth landing every time, but I can promise that if you are an inexperienced virtual aviator, you're about to get some great tips on how to smooth out that final part of the landing, the flare and touchdown. Now, last episode we talked a bit about how a stable approach is essential to a good landing. Why, you ask? Well, if you're going too fast on the approach, you're really going to float in the flare, missing your touchdown point and just screwing up your overall flying mojo. So, stay on speed during the approach. You can pick a target on the runway. This line here works great, and if you're at an airport where the runway doesn't look like this, just work it out. Just promise me you won't clip any fences or take anyone's head off. So this is your target. It's always great to have a target when landing. In fact, it's very important. Because the flare requires a bit of floating, even if you did keep your speed perfect, I've even heard of aviators aiming a bit before their touchdown point. So, for instance, you could aim here and the plane would actually touch down here. The key is to simply compensate for now and give yourself a little buffer. As you get more experience, it'll come natural. Now let's talk about the final evolution of the approach through the flare and touchdown. When you are right here over the runway threshold, you are more than welcome to pull out the power as long as you are on track with your touchdown point. So do it smoothly. Don't just cut it out. It'll make the transition a bit too aggressive. So if you do it smoothly, it'll be a nice transition that you'll be able to control. You want to do it quickly, but don't just yank the power. Now going into the cockpit, we start to ease the nose up to bleed off the final bit of airspeed. The thing is, we want it to bleed off right over the runway, not at 10 or 15 feet. We're talking about 3 to 5 feet. The tendency for you here is going to be to pull up because the runway is coming at you. Even I still have to fight this temptation, so don't be scared. The only thing to be scared of at this point is starting the flare too high, as I mentioned before. That's a sure way to slam the plane into the runway and break the landing gear. The way to do this is to use your peripheral vision out the side of your sight. And while looking down the runway, smoothly bring down your airspeed and slowly and ever so gently let it descend. This will take a very light touch on the controls, but you may also have to really command the controls as well. Just be ready. So remember, keep your airspeed in check on the final approach, pull the power when needed, and hit your mark. Use your side vision by looking down the runway to gauge how smooth your flare is. Other than that, all I can say is practice, practice, practice. Try different things, see what works for you, and hit your mark. Now, if you aren't getting a perfectly smooth landing every time, don't worry about it. Just do your best and try to improve. For some odd reason, a perfectly smooth landing became the ultimate sign of a good pilot. Well, what happens if you never make it to your destination because you did something stupid, like plan the fuel wrong, and you had to make a forced landing? Well, between a pilot that makes a perfectly smooth landing or an aviator that makes great decisions, who would you rather trust your life with? That's just a thought. Anyway, you're doing awesome so far, so keep it up. We'll see you next time when we discuss straight and level flight. Now, that sounds a bit boring, but we're going to talk a bit about the altimeter and some other things, so make sure you tune in. Until then, throttle on. We are back for yet another exciting episode of Aviator 90 from Angle of Attack. In this episode, we will discuss straight and level flight. I know you had a lot of fun in the traffic pattern, landing, and flare sections, and I promise we'll get to more landings later, but for now, we need to discuss this simple phase of flight. So, straight and level flight is something we've mentioned before, and during straight and level flight, our wings are level, and we are not climbing or descending. As you learned in the three forces section, all forces are balanced in this situation. That means that lift equals weight and thrust equals drag. We generally use straight and level flight when cruising, which I guess is perhaps a better term for this particular setup, which is cruise. There are three elements of staying straight and level. I know they may sound boring, but hear me out on this one. First, we must maintain a heading. This is simply done by turning the heading indicator's OBS knob on the heading you want to maintain. This way you can kind of target it. Well, actually, lucky for you, this aircraft, the Cessna 152, doesn't have this particular heading bug, so you're just going to have to rely on your own concentration to stick to that heading. Second is altitude. Now, I know reading the altimeter isn't something we've talked about yet, so while we have some time in this somewhat of a mundane episode, let's do that now. So the altimeter is broken up into several different parts. I'll discuss which each one is, and then we'll look at how to read altitudes. The best way to think about the hands of an altimeter is to think about the hands of a clock. The short and thick hand is the thousands of feet, and the skinny and long hand is the hundreds of feet. So if you think about it in terms of a clock, the big hand is the hours, which is the bigger number, obviously, and the smaller hand is the minutes. All right, so for example, when the thousands hand is on the 5, it indicates we're at 5,000. When the hundreds hand is on the 5, it represents 500 feet. Now, there's another hand called the tens of thousands, and this one gives us an indication for those aircraft that can climb a bit higher. Say they have an engine that can produce some better performance. All right, so both hands together, or all three, I suppose, give us a reading. But generally, for something like the Cessna 152, we'll just be using the thousands and hundreds hand. So as you can see, it'll take a little getting used to if you're not familiar with altimeters, but it's actually pretty easy. Now, if you have any questions about your altimeter settings, say you're confused or you need more clarification, feel free to ask us and we'll give you our expertise. All right, now the last part of the altimeter is known as the Kolsman window. Here we set our local altimeter setting, which you'll see during a startup procedure later in this series. But for now, just know that without this setting set correctly, we will have altitude errors. Later we'll learn where to get the correct setting and what to do if you cannot get the correct setting on the ground. The last thing I should note on the altimeter is that when everything is set up correctly, this will be your primary instrument for maintaining altitude. Now, the VSI will show you some information as to how we're climbing or descending, but it's just too easy to get focused too much on that. So our main focus will be the altimeter. It's much easier to maintain a perfect altitude with the altimeter. If you're trimmed up in the right place, your altitude should be very simple to maintain with just light control inputs based on the information the altimeter is giving you. There are those little bumps and wind differences in the air that will get your altimeter off just a little bit during cruise, but like I said, just light control input should be able to correct this very easily. All right, so that does it for the second of the three, which was the altimeter. And now that you know the basic parts, let's move on to the last of the three elements we need for straight and level flight. The last thing we need is trim. And yes, I know I've really been harping on trim, but it's seriously just very, very important that you realize trim is like a co-pilot for you. It can really help you out a lot. So I'm not going to discuss that any further, but just realize that trim is very important. Now, as a side note, the great thing about trim is that once you get it in that stable state, it really allows you to enjoy the views outside the window. Something we could all use more of for sure. All right, that does it for this episode. Remember that straight and level flight consists of those three elements we discussed, and you'll be set. Until next time, throttle on. Welcome back, my aviating companion, to another episode of Aviator 90 from Angle of Attack. Today we are going to discuss point turns, which builds upon S-turns, which we did last episode. First, what is a point turn? Well, it's really simple. It's basically all visual, and we are simply choosing a landmark, say a tower, and we are going to circle around it. Now, this may sound simple, but we'll need to compensate for wind, continually adjust our bank angle and maintain altitude without really focusing in the cockpit or with our eyes forward. This can be a task, but it is a lot of fun. So let's jump right in and try it out. First, we want to pick a landmark. There's a radio tower right over here that looks quite nice, so let's set a course to intercept that. Now we want to circle just under a mile out, or your typical runway length. And the closer you are to the object, the greater the bank angle it'll take to turn around it. So if you're too far away, it'll be a very long process, so we want to be somewhere in between. So here we are coming up on the tower. You can see it right over the airspeed indicator right now. There are some strobes on the top. And I'll peek around here. And we're going to use the left one. It's a little bigger. And that way, it'll just be a little easier to visualize this. So I'm starting about a mile out. And it'll take practice to kind of figure out how far away you need to be. Just set here. If you start about halfway down the strut on the wing, it'll work well. So here we are. We start the turn, and basically what you want to do is you have a few seconds to adjust here. Now, you want the point that you're pointing at to have everything else revolve around it. So if you kind of look at the terrain out of the corner of your eyes, you can see everything is rotating around that tower. And now we're moving in closer. So if you want to move closer to the tower or whatever landmark you're using, you'll increase your bank angle. And if you want to move away from it for any reason, say your bank angles are just too steep, you can shallow out your turns. Also, you're going to need to increase your bank angle when the wind is trying to push you away from that landmark. So right now I'm actually shallowing out my turn because the wind is trying to push me toward the landmark, and I don't want that. I want to go just the same distance. And you'll see once I get on the other side here, I'm going to have to start increasing my bank angle again. That's because the wind is coming from the other direction, basically to our left right now. So like I said before, we basically want everything rotating around this landmark we've chosen, and we also want to attempt to maintain an altitude at the same time. Now, this is really difficult in Flight Simulator because you can't really feel the airplane climbing or descending, which is basically your best indication in this maneuver on what to do. So here we are. I'm getting a little too close to the tower, so I'm going to shallow out my turn a little bit. And we're still basically rotating around it, but I'm just moving further away from it now. And that way I can get this maneuver to be a little more manageable. So now I can start increasing my bank angle because I'm at that distance that I want now. And then just making adjustments until, once again, everything is rotating around that point. Now, it's important to keep in mind that although you are rotating around that point, it's not always going to look the same. You can't really necessarily measure it from somewhere on the wing strut or think it's going to be somewhere, at a perfect place under the wing visually, because it could be very low, say halfway between the wing strut, and we'd still be rotating around it. So just make sure that you're doing a bank angle that's great enough and not too shallow, and that'll help out. All right, so as you can see, those are actually really helpful. So for an extra challenge, you can try it even closer in, or you could try it in the landing configuration, or just some different things to mix it up. Also, it's important to note that you shouldn't get in the habit of always doing it in the same direction. You'll have a natural ability to do this maneuver one way or the other, so it's probably best to work on the side that you aren't that good at, if that makes sense. So it's always great to just challenge your shortcomings. All right, this was a great episode. I had a great time, and I hope you guys did as well. Next time, we are going to do one of the funnest of all the maneuvers, in my opinion, and one of the more challenging, which is steep turns. Until next time, throttle on. Welcome to another episode of Aviator 90 from Angle of Attack. So last episode we did the enjoyable point turns. Awesome, useful, but it's time to move on to something more aggressive. So now we will do steep turns. Let me first tell you what we're going to do, and then we'll actually do it. So we're going to pick a heading, start there, and do a 360-degree turn at a 45-degree bank angle. We'll roll out and meet our initial heading after that 360-degree turn, and immediately initiate a steep turn in the other direction. Sound fun? Well, just wait. Alright, so here we are. During this procedure, we're going to maintain 2,000 feet, and we will use north as our heading. So let's get right into it here. So roll the wings and get to a 45-degree bank angle. As you can see on the attitude indicator, it's between those two marks. Now, as you're in the turn here, the way to keep your altitude is with varying pressure on the elevator. It's going to take a lot of back pressure to get your altitude the way you want it. Now, you don't want to trim in this situation, because once we roll out on our heading, then it will bubble up, and we don't necessarily want that unless we need to get a little altitude back, like I need to get here. So I'll get a little extra lift out of rolling out, and then we'll start the turn in the other direction because I was at north. So here we go again for our next 45. Again, lots of back pressure. We want to keep that horizon right in the same spot, and that's really what we're looking for here. We're not looking inside the cockpit. We just want to use the horizon. So keep it coming around. It's going to take a lot of back pressure, and try to stay right there at that 45 degrees bank. We don't need any more than that. You can use less if you need to get your altitude back. And here it comes north again, so we will roll out. So the cool thing about steep turns is the fact that it's pretty aggressive. It gives us that feel for the situations where we may need to be a bit more aggressive in the turn. Because usually what I've taught you to do is just a nice, smooth, standard rate turn, but there are instances where you'll need to use a steep turn, and you'll need to be used to it because it's a lot different. So if you want to keep going and try more of the steep turns, go right ahead. I know initially it's pretty difficult to keep that horizon and get used to the feeling of the pressure that you need to put on the yoke for the elevator. So feel free to practice more. It'll definitely help out a lot in your future aviation travels. So for now we are done. This is just a simple and fun maneuver that I like to do often, and you guys should too. Next time we will discuss the all too feared stalls. It's an important episode, so don't miss it. Until next time, throttle on. Welcome back to another episode of Aviator 90 from Angle of Attack. This episode we'll be learning about the often touchy and scary subject of stalls. Many people fear stalls because, well, it's basically a situation where the aircraft isn't producing enough lift to want to continue flying and it essentially falls. With that said, it's not something you should be experiencing unless you are practicing, so you won't experience it in everyday flying. The technical explanation of a stall would be to say that once the airfoil angle of attack reaches its critical angle, it can no longer create enough lift to keep the aircraft flying, and unless that angle of attack is reduced, you will stall. So luckily for us, we have some guesses on what airspeed a stall will happen, in addition to some other indications. We will be doing two types of stalls in this episode, a power on stall and a power off stall. A power on stall will be our clean configuration stall, done at full power, and it emulates normal flight conditions. Now, a power off stall will be done to emulate a landing. We will be at idle power in the landing configuration with our flaps down, and we will simply maintain an altitude until a stall occurs. So first, let's get to the power on stall. Here we are straight and level at 2,500 feet, so basically how this procedure goes is we will pull the power back and then we will get to where we're almost in a stall and then we will add power again. So a few notes before we get started here. It's important to always keep the ailerons neutral during your stall techniques. It's all rudder. Alright, so pulling the power back now, we want to maintain that altitude, we pull the nose up, you can see the airspeed bleeding down. We're going to get to the lower part of the green arc, and then we are going to add power again. Remember, no aileron, just rudder. So here we go, adding the power. And keep it aggressive, here we go. There's the stall warning horn, and there's the stall. Lower the nose to the horizon, and now what we're going to do is get a positive rate of climb. So now that the airspeed's fine again, look at your vertical speed indicator and get it to start climbing again. Make sure not to go into a secondary stall, a second stall. So you can see we're climbing above 2,500 feet now, and we have recovered from the stall. So that's basically it for the power on stall. It's a pretty aggressive brake, as they call it, and just make sure to keep your ailerons neutral, and it's all about the rudder pressure. Alright, now let's do a power off stall. This one is different in many ways, but in some ways it's actually very similar. The aircraft is going to brake like it did before, and we just need to recover. So again, this is in the landing configuration. So what I'm going to do initially here is start to pull back the power, and then we will start to put in our flaps. So I'm pulling the power so I get to our safe flap airspeeds. And again, this stall is much like the power on stall. It'll brake, but it won't be as aggressive because we are in the landing configuration. There's the first notch of flaps, second notch of flaps, and full flaps. So now we're going to pull the power and we're going to maintain 2,500 feet. And this one happens pretty quickly. So here we go. The warning horn. And there's the stall. Full power, recover. Pull the nose up. Need a positive rate of climb. But we also need to have a good airspeed. Alright, and one of the first things you need to do is bring out one notch of flaps once you get a positive rate again. And this process is a little bit slower than the other one. You're going to have a harder time climbing, so as you continue to climb, continue to get rid of those flaps, as that'll assist you in the climb. Alright, so that does it for the power on and power off stalls. Now, there are other types of stalls that are a bit more advanced, so for now, this is all we are going to concern ourselves with. It's also important to note that a stall can occur at any airspeed and at any altitude. Although this seems like it's contradicting to what we just learned, keep in mind that we were in a very controlled environment and the stall is all dependent on angle of attack. Alright, so that does it for the stalls. Keep practicing these stalls on your own and learn to be relatively calm and comfortable in this maneuver. It is completely controllable. You'll really thank your skills when you need this. Alright, we're done with this one. It's a tough subject and hopefully you feel like you came out on top. Next time, we will be continuing our footwork as we do slow flight. Until then, throttle on. Welcome back to yet another fun, exciting, and educational episode of Aviator 90 from Angle of Attack. Today we are going to use what we learned last time about stalls and do a lead-in to slow flight. Now, what is slow flight? It's pretty simple. We are going to teeter on the brink of stalling, and all the while we will be doing very shallow turns. Sound simple? Well, actually not so much. I hope you have your dancing shoes on because this particular type of maneuver takes a lot of footwork, and that's actually the point. So let's get set up. This maneuver will be done at a particular altitude, and for this lesson, since we're close already, let's say 2,500 feet, make a mental note of that. Also, I want you to pay special and close attention to keeping the ball in the middle of the turn coordinator. This is going to be very, very difficult. One of the first things we'll need to do is introduce flaps to the aircraft. We'll be doing this with full flaps, basically in the landing configuration, and we'll be maintaining an altitude. Now, during that time, we'll use power to get our altitude back. We aren't going to want to increase our pitch. So there's the first notch of flaps. And we'll just keep on slowing it down, staying right at that altitude, adjusting trim. All the while, there's the second notch of flaps. Again, adjusting trim, adjusting the pitch, getting all set up for this maneuver. Let's bring in the last notch of flaps. Now, we're going to maintain a heading of south on this particular maneuver. And 2,500 feet, as I talked about before. So make sure to keep the aircraft coordinated and start pulling out the power and just let the airspeed bleed down to 40 to 45 knots in that area. Now, heading is very difficult to maintain in this situation. It is definitely not easy. So I'm 100 feet too low. I'm going to pull up a little bit. I have a little extra airspeed to bleed off, so that'll help with that. And I just need to gain my altitude here. All the while, I can kind of start this maneuver. So I get back to my heading of south, and now that we are getting down to this area around 40 knots here, as you see, the controls are going to start getting really mushy. You can see there that the aircraft just turned about 30 degrees just because it's almost like a stall. It just wants to dive that direction. So like I said, you need to be very, very commanding with the footwork. So right at 40 knots, keep the power you need, and we're going to stay on a heading of south. I need to get back to that, and I've got to do it just ever so carefully. I can't just turn the aircraft over there like we would in a steep turn, or we're going to go into a stall. So it takes very minor corrections, under 5 degrees on your attitude indicator to get back to your headings or to turn to any heading you want. So getting back to south now finally, and when you roll out, it's going to be a little squirrely here, so while we roll out on south, we're going to have to adjust with the rudder pressure again, keep it nice and straight and level. Alright, so we're at 40 knots. We are on a heading of south roughly. We are right around 2,500 feet, and we are just keeping the aircraft coordinated in this very mushy and unstable situation. We want to make sure that it can't get away from us, so really stay on the ball. I know it looks like it's going all over the place here, but my feet are moving like crazy to try to keep that ball in the middle. As you can see, the aircraft can try to get away from you really quick. So what I'm doing here now is I'm actually going to turn to a heading of west. So during this time, you've got to keep the bank angle under 5 degrees, and you've really got to coordinate the aircraft. This is where it can really get away from you. And again, remember, if you are having altitude problems, power is the answer, not pitch in this case. And now heading of west there, and get all stable on west. And to be honest, this situation is almost like instrument flying. You are scanning just about everything. We want to keep our altitude, we want to keep our bank angle correct, we want to keep our airspeed. We want to keep the turn coordinated, so we're looking at that, we're looking at the heading, we're even looking at the vertical speed indicator every once in a while. And there are very few times, even in instrument flight, where it'll be this busy. Alright, so we're going to start to turn back to south, another 90-degree turn in the other direction. So again, just very, very shallow turns. Just be easy on it because it'll want to just dive that direction. But just be commanding with the controls, especially the rudder. And I'm sure it's making sense to you now. So here we are, right on the brink of stall, and the aircraft will still fly. It is still flyable, it's just extremely difficult. Now, this maneuver is great for building your skills because it really gets that footwork we've talked about all along, the turn coordination. It really starts to build that part of your control movement, that part of your brain that naturally just tells the aircraft how to control. Alright, so this is it for me now, but I really, really encourage you to do this maneuver. I know that some of the other maneuvers may have been familiar to you, but even for me, this slow flight maneuver was extremely difficult to do, and I would encourage you to jump in and try this out. It'll definitely build your skills even if you're a seasoned pilot. So next time we are going to take a break from all this stall stuff, and we'll be doing some fun takeoffs and landings. This is going to be one of my favorite sections to do because I love these types of maneuvers. So until next time, throttle on. Welcome back to Aviator 90 from Angle of Attack. Congratulations, you made it to the final episode of Air Work. We are going to talk about short and soft filled operations this time around. These procedures, much like the steep turns, will be some of your favorites. Alright, so let's do the short filled stuff first. We'll be doing both a short filled takeoff and a short filled landing. Without delay, let's dive right in and check out the short filled takeoff. So here's the scenario. Say you're at a fairly short airstrip and you also have an obstacle to climb over. Say it's 50 to 75 feet tall. Trees maybe? I don't know. This is a very nerve-wracking situation. So for this takeoff, we're going to use 1 notch of flaps, which is 10 degrees. We'll use full power, hold the brakes, and release when we're ready to let her rip. We'll rotate the aircraft right at our safe takeoff speed, and then we'll climb at VX, which is our greatest angle of climb. And in this aircraft, that is 55 knots. Alright, so here we go. Let's try it for real. Alright, so like I said, we're going to add full power and hold the brakes. So bringing in the power now. Bringing it up, holding the brakes. And release. Alright, it's going to take a lot of right rudder pressure to counteract that airspeed is alive. A little back pressure on the yoke. Not too much, and right at 55 knots rotate, so rotate now. And you maintain 55 knots throughout the procedure. Now keep everything coordinated and keep tracking down that center line of the runway like we talked about in the takeoff episode. Now right at 55 knots, keep it there. We got to get over those trees. So keep it coming up, keep it coordinated. And then once you get at a safe altitude, you can bring up your notch of flaps. Now, this is exactly what you need for a short field takeoff. Gets you over an obstacle, and it also gets you off the runway in a short distance. Alright, so without delay, let's move on to the short field landing. For particular situations like this, usually single-engine aircraft have a short and soft-field approved slower approach speed. That, coupled with your practice of hitting the mark on landing, which we talked about earlier, are way important in this situation. So no messing around. Alright, so here we go. We're going to go nuts, and I'm not even going to brief you on what we're going to do. So good luck, guys. Alright, so here we are coming around. I'm just turning from base to final now. And we are at Stark's Twin Oaks in Oregon, just near Portland. This is a nice little add-on scenery. Alright, so back to the task at hand here. Just lining up with the runway. Again, this will be done at 55 knots. Now, we want to get all slowed down and nice and stable. And we've really got to hit our mark in this situation. You cannot mess around. So I'm going to put it down right on the numbers. So bringing back that airspeed now, looks like we are doing good on our point target. I'm right at 55 knots, not a lot of power needed for now. And we're just bringing it on down. Keep it coming down, keep straight, use a little rudder, not too much. Alright, I'm going to be a little short, so I'm going to add just a little power. I'll bring it out quickly just to get over the hump here. Alright, so pull out that power quick. I need to get it down. Flare, and there we go. Now pull the elevator all the way back and use firm braking. Don't skid, but use firm braking and come to a stop. The elevator helps you with the braking. Alright, so that wasn't even that close. This runway had plenty of length. We didn't necessarily need the short field procedure, but you certainly know how to do it now in the future when you actually do need it. So short field operations are pretty fun and useful, so have fun practicing them. Now let's move on to soft field operations, which are just awesome. First, the soft field takeoff. The setup is much the same with the soft field takeoff, and we are going to use 10 degrees of flaps. However, on a soft field, say grass, gravel, or dirt, it's easier to keep the aircraft moving a bit than to have to power out of a stuck situation. So you just don't want to get stuck in the mud or something. So a few things will happen that I'll warn you about in advance. So when you're at a soft field, we don't want to have our nose dive in a rut or a hole or some other thing. So we keep a lot of back pressure on the yoke, not only in the taxi, but also during the takeoff. So speaking about the takeoff specifically, we want to use a lot of back pressure to get the nose wheel off the ground as soon as possible, but we don't want to drag our tail either. So get the nose up as soon as possible and lift off as soon as possible. That's the trick. So here we are, we're taxiing the opposite direction, and we are holding a lot of back pressure on the yoke to keep pressure off the nose wheel, and I'll turn it around here again. We want to keep our speed up a little bit. And now we are going to power up, keep it rolling here. Pointed right down the runway here. So again, we're getting our nose wheel off as soon as we can. And then as soon as we lift off, we're going to accelerate in what is called ground effects. We're going to accelerate a wingspan length right above the runway. So here we go, lifting it off. All right, we're up. Get a little extra airspeed there. And now we can follow 55 knots since we have that. And we just keep it climbing on up. And that happens really, really fast. So you've got to make sure that you keep all that back pressure. You lift off as soon as possible. You nose over in ground effect. And you pick up whatever airspeed you need to get up in the climb, say 55 knots for our nice VX climb. Then again, like before, when you need to bring the flaps up, you are more than welcome to do so, as a clean aircraft will climb much better. God, just love those takeoffs. In a lot of ways, I wish I could do them every time. They are a ton of fun. They take a lot of practice, so do your best, get used to them, and go and have some fun at some really quirky airfields here and there. So how about a soft-filled landing? What's that like? Well, the soft-filled landing is much like a short-filled landing, only we want to touch down really, really soft-like. And we also want to keep that nose wheel off as long as possible. So here we go, all set up. Alright, so here we are in base. I'm going to kind of show you this different base to final type of approach, because we're basically going to be in a turn the whole time. And this airport is actually hard to see here, but there it is, right above the glare shield on the right. So here we go. We are in our final landing configuration. Again, 55 knots throughout the whole procedure. And we're going to bring it right down, right on this grass strip. 55 knots. Got plenty of length here. A little extra power to get us flaring a little better. Hold it off, really soft, really soft. There we go, we touch down, keep the nose wheel off as long as possible. That means a lot of back pressure, and then you're just using rudder to steer, as always. And that's the best we can do, so we held it off as long as we could. We continue to hold the nose wheel off in the taxi, and I'm just gonna keep taxiing forward up here and park next to this other airplane. So practice these procedures. They're a lot of fun. I really like the soft-filled operations, and you get to see some really cool places. This scenery is just incredible, and believe me, there's better than this. Especially if you get up into Alaska, you get to do a lot of bush flying type opportunities with soft-filled procedures. So that's an instance where you can really use these procedures, and it'll be a lot of fun. So I'm just going to shut down here, pull the mixture. And that's it. So you've done it. Short-filled takeoffs and landings, and soft-filled takeoffs and landings. You aren't a bush pilot quite yet, but hey, it's a good start. You will be in no time if you go out there and just practice. So keep practicing these, as I said many times, and if you can nail these, you can easily do normal landings. Alright guys, so that's it for now. Throttle on, aviators. Throttle on.